Assalamualaikum warahmatullahi wabarakatuh to our panel. Today our group will be presenting about agriculture waste as additional material for cement in concrete. So before we start, let me introduce myself and my team member. My name is Muhammad Hakimi.
I am Agak Faris Sabri bin Afandi.
And my name is Faris Aiman Muhammad Prasetya.
Okay, I will talk about chapter 1. So concrete has been used in construction for over a century because it is strong and long lasting. It is made from cement, water, sand, gravel, and sometimes extra materials to improve its quality. Since it can be shaped easily and last a long time, concrete is a very important for building structures like houses, bridges, roads, and dams. This is the three materials we added. The first one is biochar, the second one is coconut shell ash, and the last one is palm oil fuel ash. So right here we have three problem statements. The first one is excessive generation of agriculture waste. Agricultural activities produce large amounts of waste during and after harvesting. The second one is agriculture waste management. Open burning and dumping of agriculture waste cause pollution and health risks. The last one is loss of valuable resources. Valuable organic waste that could be reused or recycled is often wasted. So this is our three objective. The first one is to reduce agricultural waste pollution, to minimize pollution caused by burning or improper disposal of agricultural waste. The second one is evaluate suitability, to test the strength of concrete made with agricultural waste as an added material. The last one is promote waste utilization, to explore the use of agricultural waste materials in making concrete. This is our scope of study. The first one is to reduce waste and utilizing agriculture byproducts. The second one is to assess these material benefits to produce environmental friendly concrete. The last one is to promote agriculture material in concrete. Research based on these three SDG. The first one is SDG 11, reduce environmental impact of cities. The second one is SDG 12, to promote sustainable management and efficient use of natural resources. And the third one is SDG 13, to make research into low carbon alternatives. So this is our significance of study. The first one is the study aims to find a sustainable way to manage and reuse agriculture waste. The second one is to investigate the potential of agricultural waste materials in improving the mechanical properties of concrete. The last one is to explore the economic benefits of using agricultural waste as a partial replacement for cement in concrete.
For chapter 2, I will be explain about introduction and additional material. First, biochar. Biochar is a carbon-rich material made from biomass. It has a porous structure, a high surface area, and contains important elements such as carbon, hydrogen, nitrogen, phosphorus, potassium, and calcium. These properties make biochar useful in concrete as it helps improve strength, reduce cracking, and make building more energy efficient. In short, biochar not only strengthen concrete but also support sustainable and eco-friendly construction. Second, coconut shell ash is formed when pozzolanic material react with calcium hydroxide during the hydration process. It plays a key role in enhancing the strength, durability, and microstructure of concrete. First, biochar. Biochar is produced from biomass. Through burning, it helps reduce agricultural waste and carbon dioxide emission. At doses of 1 to 3%, it improves the strength, insulation, and sound absorption of concrete. However, more is needed to standardize and ensure its long-term durability. Next, coconut shell ash contains a high amount of silica which form calcium silicate hydrate. This compound increases the strength and durability of concrete while also to reduce agricultural waste and carbon emission from cement production. Lastly, palm oil fuel ash POFA. POFA is an effective cement substitute that enhances the strength, durability, and chemical resistance of concrete. It reacts with calcium hydroxide to form additional cementitious compound and help lower carbon emission. The ideal replacement level is between 10 to 30%. Now let's move on to the effectiveness of the material. First, biochar help reduce the rate of water penetration in concrete, which increase its durability, especially in humid or wet environment. It also improve the concrete thermal resistance, allowing it to regulate temperature more effectively and reduce overall energy use. Next, coconut shell ash contain amorphous silica that react with calcium hydroxide, a byproduct of cement hydration, to form additional calcium silicate hydride. Or this reaction extends the binding strength in concrete. However, to achieve full hydration effective formation, the correct water to cement ratio must be maintained. Lastly, palm oil fuel ash. POFA is a pozzolanic material, meaning it reacts with calcium hydroxide. It's meant to produce extra binding compound. It also helps lower the heat of hydration, which reduces the risk of thermal cracking, especially in mass concrete structure. Now, let's move on to the data analysis which show the 28-day compaction test result for the three material. At 7.5%, biochar achieved a strength of 15.64 Newton millimeter, showing good improvement in bonding and crack resistance. Coconut shell ash with 2.5% record 8.36 Newton millimeter, which is lower but still have enhanced concrete density and durability. Meanwhile, POFA at 5% produced the highest strength, 60.23 Newton millimeter, due to its high silica content that improve the pozzolanic reaction.
Methodology: collect biochar, coconut shell ash and bottom ash, dry at 105 to 110 Celsius for 24 hours. Analyze property using SRF, SRD and ACM. Replace 5 to 25% cement with ashes. Maintain water cement ratio and workability. Cast and cure concrete specimen. Test comprehensive stress, sorptivity and durability. Compare with control mix to optimal ash level. For preparation, material: biochar, coconut shell ash and palm oil fuel ash, OPC cement, fine and coarse aggregate, clean water. For equipment, concrete mixer and weight balance, safe set and walls, tempe ropes, thrower, CTM, cooling tent and slam cone. For flow cut, we start, prepare cube molds based on required quantity, mix fine and coarse aggregate, water and cement, add additive and pour into molds, cure for 1 day to harden, submerge cube in water for 7 and 28 days, remove and perform compaction test and record result. The process start by installing the cube mold and removing the hardened concrete. Each sample is leveled and cured in water for 7 and 28 days. Before the compaction test, the cube are weighed and data is collected from the test result. Using agriculture waste in concrete offer an eco-friendly solution to reduce cement use, carbon emission and landfill waste. Material like rice hull ash, coconut shell ash, palm oil fuel ash and biochar enhance concrete strength, durability and chemical resistance, promoting greener and more sustainable construction practice.